So let's just go over a couple of your sketches. So I gave you number 24. Number 24, you had to find the area to the left of negative 3.16. Now, do negative 1, negative 2, to the left of negative 3. Isn't that really, really, really tiny? Really, really tiny. Almost 0, but we can't say 0 because everything has a little area. Because these little lines come all along but never, never touch. So as far out as you go, there will be some kind of area out there. So you looked at your table and you said, it's got to be really small according to my diagram, right? And is this small enough? Pretty small. Now, you have a little calculator set for this. Go second verse. Remember how we found your binomial? Yeah. We're on the normal curve, so it's one of those two. But this time around, we want to use a C. What the normal CDF says is, give me all your cumulative area. We're accumulating this area from left to right. So, not PDF, we want to use CDF. What it has is this. It gives you a lower limit and upper limit. And then the mean, the standard deviation. That's your standard normal curve. The mean is 0, the standard deviation is 1. So this allows you to look up a z-score as if you were looking in your table and return you the area. Later when we do the x values like we had on that other one, we can change the standard normal to a regular normal curve and change the mean and the standard deviation to get the area. But right now, we can do this in place of your table. What you have to understand is a lower and an upper. So, and I'm always coming from left to right because it's cumulative. So I'm always coming from left to right. So I'm going to come from here and stop it here. So I really have no lower limit on this. It's really coming from way, way, way out here. So all I write for this is negative 9999. Just string out a bunch of negative 999s. You'll never hit that number. My upper limit is that number, negative 316. Oops. I'm going to come down, leave my standard deviation and my mean at 0 and 1, and paste. Now this just gave us a scientific notation number. I'm going to move this 4 decimal places over. So it's giving me 3 decimals, and there's my 8. We'll try this again.
It won't let me like select it. It gives me binomial CDS.
It's the first, the second one on your list.
I guess the second bar is normal, and then pops up binomial.
Also something needs to be storing information in there. Sometimes the calculators really don't have a lot of storage, so sometimes whatever was in there before stores on top of it, clear it out, and if it still persists, do you clear your whole thing? Yes.
If the input negative 9999, would it have any effect to the message?
Not at all, because negative 999 says you're coming way out here. Would I ever have an area like so? But you want a very large number.
Okay.
Now, we're going to do it on the flip side, 99999, because we'll never really hit that number. We just have to tell them where our lower limit is. So if I was looking for the area to the left of 0, what do I expect the area to the left of 0 to be? What is the area to the left of 0? What is this area? Half of my curve. What's 0.5? So if I was going to do this for 0.5, let's see how this would work. I'm going to say I'm coming from the left, so negative 999. I'm going to stop at the 0 z-score and see if this gives me 0.5. 0.5. Your calculator sometimes gives you a little bit more. It's a lot more exact than your table is. So it might just be a little bit varied the way they round, but this one, you wouldn't round it there anyway, you would round right there. Okay? Now, I gave you one to the right. So to the right, let's take a look at to your right for a second. To the right of this number, again, isn't this a really, really small area? When I look this up, do I expect this to be larger than 50%? I expect this to be way, way less than 50%, right? Because this would be my large area. When I look this up, look at the number I get. So I say, oops, I need to subtract it from 1. And I get a very, very, very small number. Don't I expect that area to be small? What's another way to do this without having to subtract it from 1? Negative. Good. I'm going to come here to where it's symmetric and pull the same little piece of area off. So if I look for negative 3.25, I will get that same answer, 0.0006. My curve has symmetry. The distance from 0 is the same on both sides. Now, on my calculator, I'm to the right, so I go second theirs, come down to the cumulative. I'm going to do it this way first, to the right. So that's where I'm going to start. So my left boundary is right there. Whoops. My left boundary is at 3.25. That's my boundary. And I want to tell it to go on and on and on and on and on. So I'm going to say 99999. Give it a slew of 9s. I want the 0 and the 1, and I want to paste. And again, I'm moving 4 positions over, so I give myself 3 zeros. So 0.00068. I did it. Thank you. Thank you. My calculator is touchy. So there's my move it 4 zeros, 0.000, round that to 6, and there you are. If I want to use the negative, I can use the negative on this as well. Remember, it's the CDF, because you're accumulating your area. If I use the negative, my lower limit is negative 99999. I'm going to stop at negative 3.25. I keep my 0 and my 1 because I'm on my standard normal curve. And I still get the same answer. Some of you will like the calculator, some of you won't use a straight calculator. You can always use your tables. I usually get, like I said, half my class likes the calculator, the other half likes the formulas in the tables. So I like to expose you to it so that you know that it's there. All right. 33. 33 had an in-between. Now remember with the in-between, every time you look up the area to the left, that's that one, and this one's this one. So do you see where they have in common? So if you subtract that, you get what's left in between. Do not subtract your z-scores, only your areas. This one, you might like the calculator for, because this one is nice. And bear with me, because you'll like this. Second VARS, normal CDF. What's this endpoint? What's your left boundary? This is my area, these are my boundaries. What's your left boundary? Negative 1.96. What's your right boundary? Where does it stop? 1.96. The in-between is the nicest, because it makes more sense. That's the easy, and this is the hardest one to work with. Because you have to find both areas, you have to subtract them. Now watch. I put it together, there's my area. Nice, right? It does it for you. It finds the areas, subtracts them. You don't have to worry about the boundaries because they're staring right at you. I went from here to here. Upper, lower, lower, upper. So all you have to do, if you put them backwards, I'm not sure what this does if you put them backwards. But that works nice for an in-between. And when you do this, if you look it up, just say calc. Looked it up on my calc. The 40 was like yesterday's. Get used to doing this with your curve. Can everybody do this? my mean, pull out your mean, pull out your standard deviation, 21.1. Take this and add 5.3 all the way up. You only have to do this once. I did it each time just to show you where it was, but you only have to really oh, I didn't add them all up, but you only have to really do this once. Does everybody get the concept of adding the standard deviation all the way up? And then subtract it going down. God bless you. Okay, so maybe you get a better feel for where your curves fall. And then I just wanted you to find your areas. Can everybody find areas for those guys? I didn't find the areas, but I wanted you guys to. Again, give me your best bet. Do I expect this to be less than 50 or greater than 50? Less than 50. When I look at my area, I need it to be small. If it's not, I did something wrong. So your area, right? And I know that that's true. It's less than 50. It's less than my one. So again, it's less than 16 because we said plus or minus 1 was 68, so 34 on one side. So that left me with 16. So it's even less than that. So that puts me in my ballpark. This guy, I'm accumulating my area. I want to the left. It's going to be greater than or less than 50. Greater than. So I pull this in, plug this guy in, and I am 0.17. And this should say 0.5675. Good? So is everybody good with this? Finding the areas under the curve? Your area, every time you find your area under the curve, it's area from the left. This one too, I expect this to be small. Now, unusual, they ask unusual. Unusual is less than 5%. Or, if you're in terms of z-scores, anything around the 2, less than -2, greater than +2, is unusual. This is unusual, this is unusual. Because their areas, well, to this side, is real small. This is unusual. To be this far away from the mean is unusual. Remember, 68% of your data lies within one standard deviation on both sides of that mean. That's a big chunk of your data, isn't it? So as you spread out, whether the values are high or low, ACTs, SATs, whatever it is, it's unusual to get a high grade, a really, really high, as it is unusual to get a really, really low. So those grades that people said that they scored, they got really high, say, wow, I didn't know anybody that ever got that, because it's unusual. It's unusual to be as high as low. You don't want to be low, you'd rather be high. Rather be higher values on your ACTs. I said that wrong. Okay. 47 and 49. Are we okay with this, writing it as a probability statement? Everybody gets the probability? What area do I want when I say less than? Where's it pointing? To the left. Area to the left. What area do I want when I say greater than? Area to the right. I expected this one to be small. I just had you go off your probability statements. I expected this one to be small because it's area to the right of this. It's far less than 50%. Right? Yes?
The 47, since it's area to the left. Why is it area to the left?
Because less than, when what is the area when my z-score is this less than that? Less than means area to the left. Greater than means area to the right. And then when you see this thing over here, like 53, that's an in-between. Can everybody do this?
Had you area 40 again? The last step.
In which one? 40?
40.
Okay, so we just went and looked them up on your table. It's always area to the left. It didn't ask us to, but it's a good exercise just to follow your table and find your area. Or if you want, use your calculator.
Yeah.
You like a table?
I do.
Okay, a table.
I don't know.
So negative 1.15. Negative 1.1. Well, it looks different than this time you found your z-score. Before we just did the shading, we said, nice, okay, so now you have to take one extra step, find the z-score, which is what we're leading to. So I wanted to throw the areas in with those at the same time. Okay, little